Okay, so what we're going to do is we're going to take a look at Newton's laws. We're going to take a look at how he wrote them. We're going to take a look at how they were interpreted. We're going to look at how I interpret them. And then we're going to look at how you might interpret them. How is that funny? Okay. This is how Newton wrote his first law. It's in Latin. This is how it's interpreted. This is basically interpreting the Latin. Every body persists in its state of being at rest or of moving uniformly straight forward, except insofar as it is compelled to change its state by force impressed. We'll get to our language in a second. But this is how Newton expressed his first law when he wrote this book, The Philosophy of Nature, Mathematics, etc. Here's how I interpret his first law. A net force is required to cause a change in an object's velocity. So this is my interpretation. It's a statement on the interaction between a force and motion. That's all it is. This is inertia. I mean, this is how people refer to it as inertia. You have to have an unbalanced force to speed up, slow down, or turn an object. And that's the key. People understand speeding up and turning and slowing down, but they don't understand that you need the net force to turn the object also. Newton's second law is that. Now, what a lot of people don't understand or didn't know is that Newton's second law actually pertains to momentum. And we'll talk about momentum in a little while. But it's the change of momentum of a body is proportional to the impulse impressed on the body and happens along the straight line on which that impulse is impressed. We're going to talk about momentum and impulse in about a month. But Newton expressed his second law as a change in momentum. A change in momentum is an acceleration. So that's how we get the classic F equals ma. The force is based on the change in acceleration. That's change in momentum through impulse. It's like instead of saying A is equal to B, which is equal to C, and that finally is equal to D, we just said A is equal to D. We skipped all the middle stuff, which is fine. This puts a number to the force and acceleration. And this is a relationship I want you to know. For the same mass, if force goes up, so does the acceleration. And for the same force, if the mass goes up, acceleration goes down. This is the relationship you need to understand with F equals ma. You need to be able to view it this way. There's Newton's third law. No. To every action, there is always an equal and opposite reaction, or the forces of two bodies on each other are always equal and are directed in opposite directions. And of course, my way of putting it is every force has an evil twin. No force is alone. Newton's third law is two forces on two objects. His first and second law, one force, one object. How does a force affect an object? That's his first two laws. The third law is, if you have a force, there's always another force. It's a separate force, separate objects. So that's kind of how his third laws are tied together. I mean, that's how Newton wrote them. That's how I interpret them.